Good morning. I am 𝗫𝘆𝘄𝗶H, and today I'm with my partner 𝗫𝘆𝘄𝗶H, and we are going to talk about Newton's first law of motion. Now, as we all know, Isaac Newton was the first one to describe the motion of massive objects and formulate the three laws of motion. Now, these laws of motion constitute the fundamental principles of dynamics, which deals with force in relation to the motion of an object. Okay, so before we start, let us first recognize our learning objectives for today's lesson. So after the lesson, we should be able to first explain the concept of inertial reference frame, second, apply the law of inertia to describe the forces exerted on an object in equilibrium, and third, solve problem related to the law of inertia. So zero net force may actually act on an object even when it is moving. How can we say this, or how can we prove this? Kasi diba, it appears almost self-evident na that when an object is motionless, wala nagalihok, then no net force is acting upon it. Which is sure is the case, but not always. Kasi this phrase that we have right here, that zero net force may actually act on an object even when it is moving, is actually true. And let us try to prove how this is possible. So imagine at a book on a rough table, and we give that book a little push. What will happen to the book? Diba musibog siya, pero hinay, and then mo stop dayon. This would make us think that in order to keep the book moving, we have to keep pushing it, which is a misperception. Kasi if we have another situation wherein yung table natin, yung surface ng table natin is smooth, like more siya ice, like kung imagine nyo ka na mag-ice skate mo, and then yaning ato siya, very smooth, very slippery. Tapos, push natin yung book natin doon. What will happen to the book? Diba musibog siya palayo? Like, layo siya maabtan before pa siya stop. So, yung difference nito ha. Yung friction force na exerted by the two surfaces. Kasi yung polished na surface, yung ice na table natin is naturally less friction than the rough table. And without friction, what will happen to the books? Diba musibog lang sila palayo? Definitely. Hence to say that a force is needed to keep an object in motion is misleading and untrue. And this proves that when no net force is acting upon an object, it will remain at rest, or it will move forward with a constant velocity, such that no net force is required to sustain its motion. This is known as the first law of motion, that states that every object continues in a state of rest or of uniform velocity in a straight line as long as no net force acts on it. This is also known as the law of inertia, which basically says that if nothing is pushing or nag-push sa ka-object, it will either stay still or keep moving at a steady speed. Now, we don't need a continuous force to keep something in motion. It's the lack of forces trying to stop it that allows it to keep moving. Like I've said kanina that, yung misperception kanina I said that kailangan na to siya i-move or i-push sa object para move pa siya is actually not true, kasi yung nagapayok sa isang object is actually the forces. It's the lack of forces. Kanina yung we have the second example with the tabletop na smooth or ice na tabletop, it has less friction, diba, than the rough tabletop. So dito mas sibog pa siya. So that's what I'm trying to say. It's the lack of forces trying to stop it that allows it to keep moving. This tendency of objects to remain in motion is referred to as inertia, which is also the reason why Newton's first law of motion is also called the law of inertia. Now, an inertial frame of reference is a perspective considered to identify whether an object is at rest or is moving with a constant velocity.
Inertial frame of reference. First, it is a reference frame with a constant velocity, that is, it is at rest or it is moving with a constant speed in a linear direction. Second, it is not accelerating. Third, it is a reference frame in which the first law is applicable. Fourth, no fictitious forces arise from it. So first daw, ang inertial frame of reference is ga-refer siya sa kanang object kung wa ba siya galihok or nagalihok ba siya within a constant speed or in motion. So second, it is not accelerating. When the object is not accelerating, is considered po siya nga nag-refer sa inertial frame. Third, it is a reference frame in which the first law is applicable. So, sama sa giingon nga ang first law ay the Newton's first law is the law of inertia. So, ma-apply gini siya diri sa initial frame of reference. Fourth, fictitious forces arise from it. So what we say nga fictitious force or forces, it is a force that seems to be acting upon an object whose motion is characterized using a non-inertial reference frame that is accelerating or rotating. So ang pasabot da nito is ang fictitious forces kay mao ni siya nag-act as a force, like for something kay makita nga ball, i-push mo na siya atong nagalihok saya kay mao to ang fictitious forces. Sama sa gingon diri it's acting upon an object whose motion is characterized using a non-inertial reference frame. So, ang non-inertial reference frame is opposite atong nakabutang mo diri sa inertial frame of reference that sa second bullet kay dili daw nag-accelerate. So, baliktad naman sa non-inertial, which is non-inertia kay mo siya ang accelerating or rotating and many more. Ingato na siya. So, no fictitious forces arise from it. This scenario that follows will allow us to visualize the implications of inertial and non-inertial frames of reference. So, in figure A, makikita nito sa picture nga isa ka tao nasa sulod sa isa ka murag train cart sulod matawag mo itong vehicle. Kita niyo siya diya nga steady lang siya, same also sa yung isakyan. And makita din nga habang nag-accelerate tong vehicle, makita nimo ang tao sa sulod nga remain lang siya nga wala galihok. So in other term, the person is at rest. So in figure B, makita ando diri ang isa ka tao sulod sa ang isa ka tao na galihok sa sulod sa halihok na sakyanan or rain cart, di ba? And makita nimo dinhi nga patuloy gyapon lihok ang tao habang ang imong gisakyan kay it tends to slow down. Makita nimo diri habang nagalihok ka sa sulod, murag gagahinay-hinay pud sa imo ang imong gisakyan sakyanan. Example. So I think ang inertial diri kay nasa A and ang non-inertial kay nasa B, which is na-include mo diri ang accelerating, like kay ang kaingon diri sa inertial kay is it at rest daw or moving at constant speed. So mo siya kaingon diri nga accelerate po siya diri sa A. So I think that is. Now let us try to prove the first law of motion using the superposition principle. Consider the book that we described earlier sliding on a polished wet surface. If the book is initially at rest and a single horizontal force exerted upon it, the book will be set in motion. Here, the net force is non-zero, is equal to F force, mo siyang force. Since the other two forces, weight and normal force, are equal and will cancel each other, a force will be exerted on the book which is equal in magnitude but opposite in direction with the second force. The resultant will be zero. So, daw. I-prove daw nato ang first law of motion using the superposition principle. So, untay daw ang libro kay napundo ra siya or it is at rest, no? Then naay force na nag-exert ato nga book, so siyempre ang libro malihok na siya, di ba? Then there is sa second example na if the net force is non-zero and equal to force, so ang giingon no nga if ang net force daw kay dili daw zero and equal siya sa force, since ang other duha ka forces kay equal sa weight ana kung equal sa force, then dili makakanat bi siya, maka-cancel siya og kuan o something like malihok altogether, dili siya kuan ba, dili siya possible, cancel siya. Sa third, if a second force will be exerted on the book which is equal in magnitude but opposite in direction with second force, ang resultant daw zero. So nakita mo ning zero dito sa example, mo ni siya ang resultant. So if ang second force daw or ikaduhang force kay makuan sa book, ma-initiate sa book, tapos equal yang magnitude of external force siguro anak. So kung second force daw kay ma-exert sa book, di ba? And equal siya sa magnitude pero in opposite direction. For example, ang second force kay padung diri, di ba? And ang equal which is na equal daw siya sa magnitude pero in opposite direction. So this would result as your resultant will be zero. This shows that zero net force implies that there is no force at all. That is, the object is either at rest or moving in a straight line with constant speed. Objects like this are considered to be in equilibrium. Newton's first law of motion is thus mathematically expressed as follows. So, kaning F, arrow sa taas, tas something E, yung ano siya ang net force na ginagawa ni mo sa isa ka object. So, sample number 1. A 0.020 kilograms block of wood with a constant velocity slides on a rough horizontal tabletop. If there is an external force of 2.50 newtons exerted upon a block of wood, calculate the magnitude of the friction force acting on it. Let's solve. Naaro tayo. So, ang pangitaon na to ani daw is calculate na to ang magnitude of the friction force. So, sulat na to ang given. Force is that kailangan natin siya i-solve na. So, ito na nga formula kay atong may E F 2.50 newtons. 50 newton. No, diba ang F kay mo na itong ano? So the friction force. So so according to so in law of inertia na that since ang kani daw nga block of wood is galihok siya in constant velocity, wala siya acceleration, diba? Sama sa itong giingon atong inertial frame of reference nga ang inertial frame ang nag-refer siya sa object kung siya kalihok, like sa ingon, it is at rest or moving within a constant velocity. So butan mo diri kay a 0.020 kg block of wood with a constant velocity slides in a horizontal tabletop so constant velocity. So ingon na tong constant velocity, wala siya acceleration. So supposedly at-rest lang siya wala siya galihok, or maybe galihok siya within a constant speed, like kung ma-push di ba mulihok na siya, din muhunong like pinakalit muring ana. So kung wala mo siya acceleration, ang friction force niya is similar to the force. So money ang amay nga F, money siya ang friction force. Then kaning dako nga F is mo ni siya ang external force. So kung same ra sila, ay no, kung wala siya acceleration, ay mo nato nga same ra gini sila. So atong friction force diri is also to then so no, sa resultant. Okay. Sorry. So kwanta. Ang external force daw is the opposite. Nasa sa opposite direction from the force. Okay na. So resultant na to ni 0. So naway ang resultant na ka 0 kay since wala man siya ga lihok acceleration or nag-accelerate, it's possibly at rest siya. So supposedly ang result na kay 0, diba? Kay ang external force man ang friction force ay naman sa opposite direction. So imagine daw mulihok ka sa left side, mulihok ka sa right side. So asa mo siya mulihok? Diba di mo siya mulihok, naka-steady rigid siya. Kay pareha man sila nga kalihok in both sides. So steady lang, at rest lang siya. So ang answer na to is 2.50 plus negative 2.50 2.50 plus negative 2.50. So solve this calculate. Okay, so ang mo gawas kay 0. Possibly dili man dapat with 0 atong answer. So atong answer diri is also the same magyapon siya sa atong friction force of external force nga 2.50 times siya. Same naman siya kay kung same ra siya friction force of external force, same ra pud siya magnitude of the friction force man siyang answer, guys.
Okay, so let's try to solve for example number 2. We have a 180-pound cargo is found inside a freight elevator that heads upward at a constant velocity. The rope of the elevator snap which caused it to fall. Determine the A, weight of the cargo in N, and B, the normal force exerted by the elevator's support to the cargo before and after the rope broke off. So isulat sa to first ang given. We have 180 pounds. Then let's draw a free body diagram. Since ang ipangita mandariya is the weight of the cargo in Newton and our given is in pounds, we have to convert it to kilogram first and then to Newton. So we have 180 pounds. We can multiply that to 0.454 kilogram per pound to get its kilogram. So pag i-cycle natin na, magawas is 81.6 kilogram. Now, nakuha na itong kilogram, let's convert it to Newton. We will convert it with 81.6 kilogram. You can multiply that to the gravitational force of 9.8 meter per second squared. I-calculator na po nato siya. We will get 800 Newton. Kung nakuha naman nato ang weight 900 Newton, let us move forward with the B, which is ang gipangita is a normal force exerted by the elevator floor to the cargo before, which is represented by N1, and after represented by N2, the rope broke off. Now let us find the N1. Yung before the rope broke off, when the elevator was moving upward at a constant velocity, the metal slab was not accelerating. Kasi nga, it says there that constant. So meaning, zero acceleration, no net force. Now that would be mathematically expressed as F net is equal to N1 minus weight. So the net force is the difference between the gravitational force, which is the weight, and the normal force exerted by the elevator, which is katong before. Now, since the elevator is moving at a constant velocity, yung F net natin is equivalent to 0. So that would be like that. And since ang atong ipangita man is N1, we can convert that to N1 minus weight equal to 0, and we can move the negative or the weight sa because, or we can transpose it. The right term is transpose it to the other side. Without N1 is equivalent to the weight, and since nakuha na nato ang weight, then that would be N1 is equivalent to 800 Newton. And there we got it. We got the N1. Now, for the next step is yung N2. Now, after naputol na yung rope, the elevator is in free fall na. So, there is no longer a contact force exerted by the elevator's floor to the cargo. So, in this scenario, yung normal force, yung N2, becomes 0 na because the cargo is freely falling na and not in contact with any supporting surface. So, after it breaks, N2 would be equivalent to 0. And that's the answer. Nakuha na nato. Let's proceed with number 3. We have a 250-pound metal slab needed to be moved up inside a vehicle using a smooth inclined plane using the following dimensions. We have length is equal to 0.7 meter and the height would be equal to 0.3 meter. What is the magnitude of the force required to move the slab with a constant velocity? Ignore the effects of friction. Now for this item, let us first identify kung unsa ang gi-ask. So we are asked to calculate the magnitude of force required to move the slab up the incline. Okay, in solving this, let us first sulat the given. Let us write the given. We have 250 pounds, and for the plane we have dimensions length 0.7 meter and the height would be 0.3 meter. Now since ang atong given is still in pounds, to convert it to Newton. 250 pounds would be multiplied by 0.454 kilogram per pound. Same process lang. And if we calculate that na, that would be 113.5 kilogram. Now, since ako na itong kilogram, we have to convert it to Newton. 113.5 kilogram we multiply to 9.8 meter per second squared, and that would give us 1112.3 Newton. Since we got our weight now, solve na po nato yung angle of inclination, which would be sine is equal to height over length. Okay, and then we just substitute it. Have 0.3 meter divided by 0.7 meter. Then we have to solve. That would be 0.43. Now that we got our angle of inclination, and since the incline is smooth and there's no friction mentioned, the force required to move the slab at a constant velocity is equal to the component parallel to the incline. Now, kaning component parallel sa incline, this would be represented by weight of x. And we have to solve for that kasi mathematically, it would be expressed as multiplied by sine or the angle of inclination. So we got our weight now, we have 1112.3 Newton multiplied by 0.43. Then 12. That would give us 478.29. 478.29 Newton. Now this is now our parallel to the incline. And since 𝗶𝗵𝗆 is yung magnitude ng force, we will have to apply the law of inertia. So we have this formula. We have this formula, which means that the forces involved are the weight of the metal slab, just the weight, which is represented by W, and the force required to move it up the incline. And since there is no friction mentioned, like I've said, the only force parallel to the incline is the component of the weight, which is katong parallel. So the equation becomes like this, and since F is equal to the force required to move the slab is equal to the component of its weight along the incline, we can simplify it to transpose na lang natin na para ma-simplify. That would be F would be equal to weight of X, or the component that is parallel to the incline. Okay, so since we already got this, just substitute 478.29, and there we got it. Got the answer. That's the final answer. So the magnitude of force required to move the slab up the incline is still 478.29 Newton, which is also the weight of the component parallel to the incline. So that's it. Also, we have some items here that you can answer to practice for this lesson. And that's it. Thank you for listening.